Okay, so word embedding. Let's try to see what word embedding is. Word embedding is basically a way to represent words or sentences into a numerical format. Mostly word embedding is used with NLP, natural language pre-processing or natural language processing. And in NLP, you have sentences and you need to work with sentences. Your model can't understand text or sentence. So what you try to do is you try to convert it into a numeric format, into a numeric manner. And here is where word embedding comes to your play. Let's say I have two sentences, hello, how are you doing? And hello, how are you feeling? So a vector representation or a numerical representation of this is necessary to give it as an input to my model. Let's say we try to integer encode or basically ordinal or label encode this. So give hello as 0, how as 1, r as 2, u as 3, and doing as 4. But it won't give you a semanticness in the sentence. And it is also not a ordinal thing or a ranking thing. So you can't label encode or ordinal encode this, right? We have discussed this in earlier video. We can't do that. But now, let's say we try to one-hot encode and create a new column for each word. Hello, how are you doing? And then what we do is when there is occurrence of word hello, we will try to give it as 1 and other columns will be marked as 0. This can be done, but the problem with this is just to represent a hello, I'll need to use whole vocabulary. In this case, I have 0, 1, 2, 3, 4, 5 words. So just to represent hello in a 5-word sentence, I'll be requiring dimension 1 by 5. Let's say my vocabulary is of more than 1000 words. So to represent a single word, you will give that word, you will mark the word where the occurrence is as 1 and other as zeros. So to have a vocabulary of more than 1000 to represent a single word, you will be needing 1, 1000 as a dimension for representing each word. Okay. This is the problem with your one-hot encoding. If you try to see, to represent hello, I'm needing 1, 5 dimension and most of the cells are 0. This is also called as sparse vector. In this vector, most of the values are 0. This is called as your sparse vector. It is computationally inefficient and costly. The solution to this is word embeddings. And in word embedding, what you can do is you can give an input that I want each word to be represented in a vector of 2 dimension or 3 dimension or 4 dimension. So in this case, what you're trying to do is you're trying to represent each word into a 2 dimension. Okay, so the hello, you will represent hello as 0.04 and minus 0.033. Okay, this is representation into your word embedding format. In dense vector, this vector is called as your dense vector. Unlike sparse vector, in dense vector, you don't find 0 easily. Okay, dense vector is opposite of sparse vector. This is official page of TensorFlow. They have tried to explain this. In this scenario, if you see one-hot encoding, cat, mat, on, sat, the, they are representing the word the with 0, 0, 0, 0, 0, and 1, because this is a separate column for the. Okay, for sat, they will be representing this 0, 0, 0, 1, 0. If you see this key point, this approach is inefficient. Why? Because they are using sparse vector, right? Imagine with the 10,000 words of vocabulary. To overcome this, we have come with word embeddings. It is an efficient way and it uses dense representation. It uses dense vector, right? So each word is represented in 4 dimensions. Cat is represented in 4 dimensions, mat in 4, on in 4. This is what your word embedding looks like. Word embedding takes 3 inputs. First is your input dimension, which is size of your vocabulary. Output dimension, length of the vector for each word, and input length, which is maximum length of a sequence. So when you give in a sentence as an input, it is a sequence. So what should be the maximum length of the input sequence? It takes 3 things as an input: input dimension, output dimension, and input length. There are these 3 parameters to your embedding layer. Thank you. This was all for this video.